Hello everyone, this is Dr. Maha Abdurrahman. Today I'll be reviewing the ionic bonding. And before I start reviewing ionic bonding, maybe you would wondering what does this picture has to do with it? Well, actually, this picture says it all because it shows you that when sodium, which is this metallic metal, soft metal on the left, reacts with chlorine, which is this yellowish gas inside this bottle, how when the sodium reacts with this chlorine, guess what it gives? It gives the sodium chloride as a product. And maybe some of you may not relate that the sodium chloride is the table salt. It's the table salt that we're eating, that we're using every day on the table. So basically this gas, this chlorine gas, it's an irritant gas. That's to say, if you inhale it, or if it's a liquid chlorine, it can bleach clothes. Sodium, if you react it with water, it can explode, okay? But when these two things, or when this sodium react with this chlorine, gives me something that I can eat, that I can use as salt to flavor my food. How this is possible? This is one of the secret of chemistry, and this is how ionic bond will kick in to explain what's going on here. Okay, so let's go deep into that, and I'm gonna share with you this picture over here. Oh, some dogs are barking. Okay, it's still all right. So if I'm gonna look at this, that's a part of the periodic table, and it really shows you the electrons around some of the metals and some of the non-metals. So if I see here, that is group 1, that's group 1, that's group 2, that's group 3, group 4, group 5, group 6, group 7, and group 8. And if you want to relate if you look at group 1, you would notice that the last electron in the last shell here is only 1 electron. So it's got a 1 electron on the outer shell, okay? While group 2, it has 2 electrons in the outer shell, as you see here. Group 3 has 3, group 4 has 4, 5 has 5 electrons in the outer shell, 6 has 6 electrons, 7 has 7 electrons in the outer shell, and 8 has obviously 8 electrons in the outer shell. So the number of the group would give you the amount of the electrons in the outer shell, okay? What this has to do with the formation of ionic bonding, okay? Now, the atoms are just like people. They tend to become in a stable position, in a favorable position. But for the atom, the favorable position or the stable position is to have a complete outer shell, okay? Now, to have a complete outer shell, maybe a lot of you knows that the complete outer shell is to have a full or a complete outer shell. If I'm talking about the second shell, for example, for sodium, okay? Sodium already has how many shells? Let's check. 1, that's the first one. 2, 3, so 3 shells that has electrons if you're looking at the sodium. So for the sodium to have a complete outer shell, it will need to have an 8 electrons on the outer shell. 8 electrons in outer shell, which is gonna be okay, that's a good question. Is it gonna be shell number 2 or shell number 3? Is it easier for the sodium to lose this electron up here and then have a second complete outer shell? Or is it easier to gain 7 electrons on top of this? So on top of this one, is it easier to gain 7 electrons? Or is it easier to just lose this guy and then have a complete outer shell? Obviously, the answer is for sodium, it is easier to lose this electron and so have a complete outer shell. This is a very stable position for that. Okay, so that means for all group 1, are they gonna react by losing 1 electron? Yes, so hydrogen will lose 1 electron Lithium will lose 1 electron, have a complete outer shell of 2 electrons up here. Sodium will lose this electron, have a complete outer shell of 8 electrons. So for potassium, it will lose 1 electron and have a complete outer shell of 8 electrons, okay? Which is this one, okay? Now, when these metals lose, well, obviously, group 2 will lose 2 electrons, which are the 2 electrons here in the outer shell, because when these guys are lost, so these electrons are lost, they would have the stable configuration or the stable electronic configuration, which is composed of the complete outer shell, okay? If you notice, guys, I'm not explaining into details and I'm not digging into details because this channel is just a revision channel. So I'm explaining for a student who has already got the background, okay, and I'm just revising them what is ionic bond, okay? So I'm not digging into details for this, all right? Now, so just to remember, or just to remind you, this is the reason why metals will lose electrons, okay, which is group 1, 2, and 3, and then these non-metals, group 5, 6, and 7, because it's easier for group 5 to gain 3 electrons to have a complete outer shell of 8. Group 6 will gain 2 electrons to have a complete outer shell of 8. Group 7 will gain 1 more electron to have a complete outer shell of 8 electrons. Now, the big question, we said metals will lose and non-metals will gain electrons. The big question is, these electrons that the metals has lost from the outer shell, where are they going to go? They're not disappearing, right? Because according to the law of conservation, nothing can appear or disappear. So these electrons are not disappearing. They're actually moving from the metals to the non-metals. So basically, if I'm talking about, let me give you an example. So if I'm talking about the lithium being reacting with fluorine, for example. So basically, this electron here that will be lost from the lithium, it will be gained by the fluorine. So basically, fluorine will take the electron that has been lost from the lithium. Well, this happens when lithium reacts with fluorine. So basically, when lithium reacts with fluorine, lithium will lose 1 electron, fluorine will gain this electron, it will form the lithium fluoride, which is the ionic compound. So let me write that again over here. So when lithium reacts with fluorine, it will give me the lithium fluoride, which is my ionic compound. So that's to say, ionic compound will form when electrons is lost from metals and gained by the non-metals. That's right. Okay. So let's have a quick look over this page as well. This shows exactly what I said, or what I explained, or what I revised. So this sodium, that's the electronic configuration of the sodium. This 1 electron here will be moving to the chlorine. Well, this happens when they react. Now, one very important thing that I want to stress on, when the sodium loses an electron, it lost a negative entity. So this is why you will see a positive charge on the sodium. Well, I will call it here ion, because we all know that the atom is neutral. So it's not an atom anymore. That's a sodium atom, right? Let me just enlarge it a little bit for you guys. So, okay. So I'm enlarging it here a little bit, so I hope it's clear for everyone. So that was the sodium atom. It's neutral, okay? And it has 11 electrons, 2 in the first shell, 8 in the second shell, and then 1 last electron in the last shell. This lonely electron will be lost to the chlorine, as we mentioned. In this case, after the sodium loses the electron, it will form sodium ion. Chlorine, when it gains electron, it's not a chlorine anymore. It's always remember the picture that I posted at the beginning of the video. Chlorine is the yellow gas, okay? But when this chlorine loses the, the electron and becomes chloride ion, this is a completely different thing. So chloride ion is completely different than chlorine atom. This is the mystery the astonishing part of chemical reactions, that they're giving you a completely new product. Always remember the picture that I posted in the first video. So this is the sodium ion, that's the chloride ion that form the sodium chloride. What is sodium chloride? It's the table salt, okay, which is composed of sodium ions and chloride ions. What make the sodium and the chloride ions bond together? It's the different charges. So sodium has a positive charge, chloride has a negative charge. This attraction between the two oppositely charged ions is what form the ionic bond. I believe that makes sense right now. I'm gonna share with you a question, but before I do, I just want to go over magnesium and oxygen. If you look in here, magnesium is in group 2, okay? So it has the 2 electrons in the outer shell, these 2 electrons. Oxygen in group 6, so it has a 6th electron in the outer shell. So basically, these 2 electrons from the magnesium is going to moving to the outer shell of the oxygen. So now the oxygen has a complete outer shell of 8, and the magnesium also has a complete outer shell of 8. Magnesium lost 2 electrons, so it will show the Mg plus 2. This plus 2 showing that it lost 2 negative parts or 2 negative electrons. And oxygen has a negative 2 showing that it has 2 extra electrons. That's why it has a negative 2. And really the attraction between the positive ion and the negative ion is what forms the ionic bond or the ionic compound. In the next video, I will talk about the properties of the ionic compound, but I just want you today to understand how the nature of the ionic bonds, what makes the positive ion and the negative ion bonds is really the difference in charge, okay? This attraction between the 2 oppositely charged ions, and what makes these ions, or what forms this ion initially, it's the losing of the electrons in the metals and gaining of the electrons in the non-metals. That's why always the metals will form a positive ion, yes, because they always tend to lose electrons. The non-metals will form a negative ions all the time because they tend to gain electrons. I hope this is clear, and I really gonna okay, before I share the question that I've prepared for you, I just wanna point another example, okay, which is the sodium and the oxygen. If you look in here, you will see that 2 sodium atoms is reacting with 1 oxygen atom. Why does that? Because if you see here, sodium has only 1 electron in their outer shell, while the oxygen, as I mentioned, it needs to gain 2 electrons to have a complete outer shell, because it needs 2 more to make up the 8 electrons in the outer shell. So this explains why oxygen will react with 2 sodium ions, because basically it needs 1 electron from each outer shell from each atom. So we will see that the sodium oxide, it's an ionic compound. It's made up of 1 ion of oxygen, as you see here, and 2 ions of sodium. And don't forget, guys, we can't say atom anymore. So when I'm talking about this compound, I should say it's made up of an oxygen ion and 2 sodium ions. These are not atoms anymore. These are ions, because this sodium already lost an electron and this oxygen ion already gained 2 electrons. And this is what forms the ionic bond. I hope the nature of the ionic bond is clear. Now, the last thing I will share with this video is a question, a past paper exam question, which is this one. And this figure shows, so I just really want to show you how the questions coming. If you understand, you will be able to answer any type of questions about ionic bonds. So this figure shows the outer electrons in an atom of a group 1 element potassium and in an atom of group 6 element sulfur. So basically you have, this is the potassium, okay, and this is the sulfur. Potassium is in group 1, that's why it has 1 electron in the outer shell. Sulfur is in group 6, you will notice it has a 6 electron in the outer shell. Now, potassium forms an ionic compound with sulfur. Describe what happens when 2 atoms of potassium reacts with 1 atom of sulfur. And initially, this is exactly the second or the third example that I shared with you today. Remember, for the sodium oxide, it's typically the same. So why there are 2 atoms of potassium that is reacting with 1 atom of sulfur? And give the formula of the ions formed. So this is exactly the case that I shared in the final example. So I would say that potassium is or will lose 1 electron, okay, and form the K plus ion, right? And then sulfur will need to gain 2 electrons, right, to form the sulfur -2 ion. So because oxygen will form, because potassium will form the potassium plus ion, right, it will lose only 1 electron, and sulfur will need to gain 2 electron. So it makes sense that sulfur will need to bond with 2 potassium ions, right? So sulfur ion will need to bond with 2 potassium ions, okay? What kind of bonding is this? It is an electrostatic attraction. What is electrostatic attraction? They love you to say this word, electrostatic attraction, which is the attraction between the two oppositely charged ions. That's it. And then you gain your, I believe that's a 5 marks question, I believe. Yeah, that's a 5 mark question. And then you gain your 5 marks. Easy peasy. Then you get your 5 marks because here we mentioned all the key points or the keywords. That potassium will lose 1 electron to form the type of ion. They already want you to mention the name or the formula of the ion. Sulfur will gain 2 electrons to form the S-2, and then talk about the attraction between the 2 oppositely charged ions to form the ionic bond. That's it. I hope this short tutorial was useful for the nature of the ionic bond. See you in the coming videos. Have a great day. Bye.